Welcome viewers. Today we are going to discuss optimization of warehouse distribution. This particular topic is from your course MWR03, that is warehousing system, which is a part of your program, postgraduate certificate in inventory planning and warehousing system. I am Professor Ashish Agarwal from School of Engineering and Technology and the program coordinator for this program. You will be surprised to see that in warehouse, in inventory, we need to optimize the distribution, because in warehouse the material used to come from factory or manufacturing unit to warehouse for going to the market. Before starting any optimization technique or model, let me explain you what is inventory. Inventory refers to the collection of goods, materials, resources that a business hold in bulk for the purpose of production. Basically, what happens that it is stored or it is taken in anticipation of its use in future. But inventory for any organization, for any establishment, it is a very important. Now the question is where we have to keep the inventory. It is the warehouse. Warehouse is a place where the inventory is stored. You will appreciate that all the finished good or semi-finished good or any item required for the particular manufacturing a product cannot be accommodated in a manufacturing unit. Therefore, warehouse is required. Even you will be surprised to know that when the car or refrigerator or air condition or television, when they used to come from the manufacturer, it does not directly goes to the dealer or at the shop. It remains at the warehouse, and as per the customer need, the dealer take the item from the warehouse and deliver to the customer. So if we see that definition of warehouse, warehouse is a place where we keep the product for the use in future. So warehouse, basically they are used by all the different type of business, and the purpose is storing the physical inventory for the sale or the distribution. It is used before either for shipping or shipping to other location or to the end customer. There are two purposes. Now, third important point, which is a warehouse distribution, which is the main topic of today's discussion, that even in warehouse, we need the warehouse distribution. That means material movement and the transportation. There are two major activities in any warehouse distribution, and for doing so we need to allocate the people, because one has either to work on the trucks or the vehicle from movement from one place to another place, or keeping the material from truck to the shelf. So we need the different models so that the cost can be optimized, time can be optimized, profit can be maximized. So all these comes as a warehouse distribution. Now in today's session, we have kept only two objectives. The first objective is to learn about the optimization solution, because in the transportation of material from one place to another place, we have a transportation model. And the basic problem is that there are so many facilities from where we have to take the material to the different facilities, and the cost is involved, time is involved, human labor is involved. So we need a model which is useful to optimize the total cost, total time, total labor hour. It is very important here, and we will also provide you the importance of each model, that what is the optimization, what is the importance of optimizing the warehouse operations and the allocation efforts. Now we come to the transportation model. Basically, transportation model is nothing but it addresses the concept of moving thing or product or item from one place to another without any change. Without any change, that physical appearance will not change. The particular product is shifted or placed or moved from one place to another. Another assumption we take in the transportation model, that any damage in the route or any change in the route is in negative consequences. That whatever route is decided in the transportation model, that remains constant and that is fixed. And our objective is to find the most efficient route for the source allocation. Now, what is the transportation model? It is based on some optimization technique, just like operation research or linear programming. Its application improves the productivity, and most important, it is a cost curtailing. Basically, we try to optimize the cost. In short, the transportation problem is termed as TP, and it is composed of some physical distribution of resources is to be made from one place to another place to meet certain set of criteria within the given availability. You just focus on this particular first point, that whatever is or what will be the requirement. Requirement may be the demand at the marketplace. Now, what is availability? Availability means that whatever product we are producing, that is the availability. Now, that availability is to be matched with the demand. That may be the warehouse demand, that may be the market demand, that may be the customer demand. The place from where it goes or where it starts. In other words, I can say that where the production is taking place. This is called as a source or the origin. This source or origin will have the availability or the capacity or supply of resources. That means they have the generation capacity or the production facility. On the other side of this transportation is where the resources are transported. These are called the sinks or the destination, just like market centers or the godowns. For example, breads are prepared in a one or two manufacturing unit, and from there it goes to various location. For example, if bread is prepared in Delhi, then the market may be Gurgaon, maybe Ghaziabad, maybe Noida. All these, even Delhi also. So there are 4 or 5 markets where whatever is produced in the origin or in the source, that has to go to the sink or the distribution center. So this is the some of the beauty of the transportation model. This will have certain requirement or demand. The warehouse or the sink or the ultimate place where the material or the product is to be transported, they have certain demand. So there are 2 things. One is the supply and another part is the demand. Now, what is the standard and the balanced transportation problem? A transportation problem is generally considered as a standard if it is computed to minimize the total cost. Because what is the objective of any person or any organization? They always want to minimize the waste and to minimize the total cost. So this is called the standard problem. But in case the transportation model is for maximization of profit, then it is considered as a non-standard problem. Now in today's session, we will concentrate on the minimization problem. You will just see the figure. On the left side, you have a factories 1, 2, 3, and on your right side, we have a warehouse. So we have M sources and N destination. Transportation models are used, or the problems are used to find the minimum cost of transportation of goods from M source to the N destination. Now remember that warehouse is only a temporary place. From here, the goods has to go to the different marketplace. It may be dealer, and the dealer may have a small type of a store where 10 to 11 or 20 vehicles can be kept. But if we need more variety, then the dealer has to reach to the warehouse. Now, a transportation model or the problem, if we define it, it is basically a linear programming problem. A linear programming problem is particularly a problem of operation research, where you have a certain objective function. For example, here we have an objective function of minimization of cost. Then we have a certain constant that has to fulfill. For example, in transportation model, we have a constant as the supply and the demand. And the third one is supply should meet the demand. Or there are some other constant also that we will see in the coming slide. And the transportation problem deals with the identification of optimal solution for transportation and allocating resources to various destination and from one site to another site while keeping the expenditure to a minimum. Expenditure means here the transportation cost. Here you will find on your left hand S1, S2, S3 are the source of supply, and the A1, A2, A3 are the availability of resources at this end. On the right hand side, green color, we have a warehouse D1, D2, D3. It may be the market, means D1, D2 up to N. And the demand is B1, B2 and Bn. And if you just see, we have 3 lines from S1 to D1, D2 and Dn. There are multiple if the number of warehouses are more. And you will see that C11 means the cost of providing X11 item from source 1 to warehouse 1. Similarly, others are self-explanatory. This is a basic transportation model. Now, how you will formulate the transportation problem? Let us assume that OEM, that means original equipment manufacturer, is supplying the resources or the different products from M source to N destination. Source SI and destination may be DJ. AI is the quantity available at source SI, where Bj is the quantity required at destination D. Cij is the cost of transportation of 1 unit of resource from Si to Dj. If Si is 1, Dj is 2, then the cost will be 1, 2. Xij is the unit of resource transported from source Si to destination Dj. Another important constant which is written in the last line, that the quantity M which is available at source should always be greater than 1. Similarly, the demand should be always greater than 1. Another important point which I want to stress here, that supply cannot be negative, demand cannot be negative. This is a basic model of a transportation problem. On the left side, you will see O1, O2, O3 and On. They are the origin or the resource. While as a column, if you just see, these are the rows. And the column you have a destination D1, D2, D3 and Dn. They are warehouse or destination. At the bottom of this matrix, there is written requirement or the demand. That means each destination or each warehouse has a certain demand, that is B1, B2 up to Bn. Similarly, if you go on the right side of the column, for each row you have a availability or the capacity. That means each origin has a limitation. It cannot produce more than the capacity which is available or which is specified. So this is basically a simple transportation problem. Now there are many types of transportation problems. Typically, transportation problems are broadly classified into the balanced and the unbalanced problem, depending upon the source supply and the requirement at the destination. If you just try to understand that balance and the unbalanced term comes between the supply and the demand. In the coming slide, we will be able to understand more clearly. In case of balanced transportation problem, total supply from the sources is equal to total demand by the destination. Mathematically, we can represent it by summation of all the supply from all the sources that should be equal to the demand of all the destination. Now, what happens when you have a unbalanced transportation problem? The total supply is not equal to the total demand. That means summation of availability at resources is not equal to the summation of demand at the destination. There are two cases. In first case, the supply can be more than demand. In this case, a dummy destination is added in the matrix with the zero cost element. Second situation is that when the supply is less or the availability is less than the demand. These two are the very practical problem, and where the organization or the companies face this type of a situation every day. In second type, availability is less. In this case, a dummy source is created with the zero cost element. So these are the three situations. First, when the total supply is equal to total demand. Second, total supply is greater than total demand. And third one is total supply is less than total demand. Now, let us see this matrix where you will find on the left side you have a source 1, 2, 3, 4, and at the top of the matrix A, B, C are the destination. You have a demand of destination. For A it is 7, for B it is 9, for C it is 18. So the total demand is 34. Now if you go the supply position, from source 1 it is 5, source 2 it is 8, source 3 it is 7, and source 4 it is 14. So the total is 34. Here you will see that the total supply is equal to total demand. This type of transportation problem is called as the balanced transportation problem, where supply is equal to demand. Now let us see the problem 1, unbalanced transportation problem, where supply is less than the demand. You just see, and if you add 5 plus 8 plus 7 plus 12, you will find the supply is only 32, and if you just sum up 7, 9, 18, you will find the figure 34. That means your demand is more but supply is less. So here what is required to be done? We add a row as a source and we add the supply as a 2. So the total supply is now become 34 and the demand is also 34. So what we have done, we have transformed unbalanced transportation problem into a balanced transportation problem. Now let us see another type of unbalanced transportation problem where your demand is less but supply is more. If you add the supply, it is coming as a 34. If you add 7 plus 9 plus 16, then what you will find as a 32 That means demand is less and the supply is more. So what we have to do? We have to create or insert a column which is a dummy destination. The demand is for each, the demand is 0, or the supply for each case. That means the origin A1 is supplying 0 item to that particular destination. Now if you just add, what we have done, we have created a dummy column with a demand of 2, but the cost is 0. So what we have done here also, that we have transformed unbalanced problem into the balanced problem. So in today's session, we have defined the transportation problem, what is the importance of transportation model in a warehouse, and I have just given you the basic idea of the transportation model. In the coming session, we will try to have many models just like northwest corner method, least cost method, and Vogel approximation method, Modi method. All these methods are very useful and they are the important part of your course MWR0103, which is a warehousing system. I trust that this session will build a foundation to understand the transportation model, to understand the most typical problem of the transportation. Thank you. Welcome viewers. In transportation model, or when we deal with the optimization of warehouse distribution, we have two types of problems. One problem is transporting the material or the product or the goods from one place to another place. That means source to destination. And our objective is to optimize or minimize the cost of transportation. This problem is known as transportation problem. Another problem is the allocation. Suppose there are 5 persons or truck drivers. Each has a certain efficiency, or you can say different types of characteristics. So on the basis of that, we have to allocate each truck to each person. One person cannot be allocated or assigned 2 trucks. Similarly, two persons cannot be assigned to a single truck. So objective is each driver, each truck. So this is a second type of problem in the optimization of warehousing distribution. The first type of problem is called as a transportation problem, while the second type of problem is called as a assignment problem. Why we need the allocation model? Because every warehouse experiences allocation problem daily, particularly to assign people for jobs or drivers to vehicle or workers to the counters. Because there may be several counters, and in each warehouse you have to assign every day worker to each counter. Scientific method such as assignment model, crew assignment, traveling salesman problem for allocation of warehouse jobs can be used, and they considerably reduce the time, cost and effort. In this session, we are dealing with a particularly one assignment model, and in the coming sessions we will try to solve one or two assignment problems with examples. So in today's session, what is our objective? We will learn the importance of optimization, warehouse operational and allocation efforts. Second, we will try to have the feeling that how to solve the practical problem by using a Hungarian technique of assignment model. Now, how you will define the assignment model? As you know that anybody can do any job, but all the men will not have the same efficiency, skill and the knowledge on all the jobs. Suppose I take the example of truck driver. Each driver has its own skill and the efficiency. One can drive 50 kilometers per day per hour. Another may have the better efficiency, or another may have the lower efficiency. So depending upon the variation of their capabilities, efficiencies, the jobs are to be assigned according to their abilities. The purpose or the objective is to maximize the output in a minimum time. Now, how you will apply the assignment model to the warehousing? Often in the warehouse, we have to assign jobs depending upon the experience and the common sense of the optimization fleet manager, which may result in success in some cases, or in some cases it may result as a failure. The model or the method is developed by a Hungarian mathematician, D. Koning. That is why it is called as a Hungarian method. Now, how you will formulate this assignment problem? You have n facilities and n job. Another important thing that in transportation model, there is no need to have the square matrix, means row is equal to column, but in case of assignment, square matrix is necessary, essential, and we have n facilities and n job, and the effectiveness of each facility for each job. Now the problem is to assign each facility to one and only one job in such a way that the measure of effectiveness is optimized. Either it is maximized or it is minimized. Now, there are several problems faced by management which are very, very identical to the assignment problem. A departmental head may have 5 pupils available for the assignment and 5 jobs to fulfill. He or she may like to know which job should be assigned to which person, so that all these tasks can be accomplished in the shortest possible time. Now, suppose we have a truck. Take the example. There are empty trucks and the trucks has to be assigned to the different cities. Now, we have to assign the trucks in such a way so that the total distance can be minimized. In a marketing setup, by making an estimate of sales performance for different salespersons or salesmen as well as for different territories, one can assign it a particular salesman to a particular territory with a view to maximize overall sales. So this becomes a maximization problem of a assignment. This is basically a matrix, as I told you, that in assignment model the matrix should be square, where number of rows should be equal to number of columns. Now these are the sum of the steps. Remember, in today's session we are not taking any problem. First we want to build up some theoretical base in you, so that when we start with some mathematical problem, you should be able to better understand and you should be able to formulate and solve the problem. So step 1, you have a statement from where you have to generate the matrix, which is normally a square matrix. How to deal when your matrix is not a square, that we will discuss. Now formulate the given information. Generally the cost or the profit contributed when they perform the job in the form of matrix, certain rows which may be the man or the vehicle, and the column which are certainly few jobs. Now second step, as in case of transportation problem, we have 2 types. One is standard, another one is non-standard. The objective may be either to maximize the profit or to minimize the cost or the time. When we talk about the cost minimization or any minimization, then it is called as the standard form in assignment problem. If we want to maximize the profit, the given problem is to be first converted to the minimization form by using one of the following rules. Please try to understand that in case of minimization problem, we have nothing to do anything extra. But if our objective is maximization of profit or maximization of profit or availability, then first we have to convert the maximization problem into the minimization. Now how you will convert? First thing, that try to identify the maximum cell value. Then subtract all the cell value from it to get the corresponding cost value. Definitely when you will subtract from the cell value, the maximum value, you will get the negative value. Now as a second step, multiply all the values with the -1. So you have all the values in a positive value. And second important thing is your maximization problem is now converted into the minimization problem. Now step third, the name of this step is your balancing. An assignment problem is said to be balanced if the number of rows is equal to the number of columns. The matrix is square. What is the meaning of that? That means if we are having persons and the jobs, if we have 5 jobs, then our operator or the driver of the persons are 5. 5 person has to perform the 5 jobs. That is known as a balanced problem or the balanced. Now what you will do if your problem is not balanced? There are again 2 situations. First, either the number of persons are more than the number of jobs, or number of jobs are more than the number of persons. In other statement, we can say if the number of rows is not equal to the number of columns, then what we do, we add a dummy row or dummy column with some assignment cost as 0 for the dummy cell, unless and otherwise specified. If we have specified something, then we will take that value. But here I just want your kind attention that what is the meaning of number of rows is less than number of columns? That means your number of persons are less than the number of jobs. In the vice versa, number of columns are less than the number of rows. That means number of jobs are less than the number of persons available. Here again, if the number of columns are less, you have to add 1 column. If your number of rows are less, you have to add 1 dummy row. This is the basic step, because unless and until your matrix is a square matrix, you will not be able to apply Hungarian method. Now what is step 4? Step 4 is also called as the opportunity cost matrix. We have a first row operation. In the row operation, what we do, we try to locate the smallest element in each row of the cost matrix and subtract it from each element of the corresponding row. Suppose 5, 6, 7, 8 are the numbers, then the 5 is the lowest, then we will subtract 5 from each one. The basic idea is to have the 0 value, because we want that the particular person, if does that particular job, it takes the 0 amount of the time or the cost. This is the basic purpose. More clearly, subtracting smallest of first row from all the first row element and the smallest of second row from the second row, and so on. What we will get? We will get at least 1 0 in each row. Then how to deal with it, let us see. Now there is one important tip, how to cross check it. Now for each row and each column, there must be 1 0. And there should not be any negative value. If you are getting any negative value, that means there is a mistake. And important thing is that if you get at least 1 0, then your iteration can be stopped. Otherwise, you carry on unless and until you get at least 1 0 in each row. Now, step 5. Now, we have, after opportunity cost matrix, it is time to make a assignment. Now, how you will make the assignment? Now, you have at least 1 0 in each row. So, what you will do? Assign a 0 in each row by marking a box or a square or rectangle around it. And this is called as the assigned 0. The purpose is that we are allocating 1% to one job. And the most important thing, when you assign something, please make other 0 as a cross. That means that job cannot be assigned to another person. Similarly, that row will, you have to cross all the zeros except one which is assigned. That means this person cannot be assigned another job. So the purpose is very simple: one person, one job. Now, what is a tip for this particular step? Always it is better to start with a row or column that contains only 1 0. That means you may also face a situation where there may be 2 zeros in a row or 2 zeros in the column. So the most important point or the tip is that you select that row or column which is a single 0. Now this is one of the example you have seen, and how you are allocating. You just see at the topmost is the basic example, and this is a transformed as a opportunity cost when we are going to assign. You will see, if we go for the first row, we have a first man. If it is assigned job A, it takes 30 unit of cost, B 10, C 0, D 10. This is after several iteration. So since we have to see 0, and the important tip is that we have to select a row which is only 1 0. So you just see that first row is only 1 0. So what we have done, we have assigned job C to operator 1. Now what we have to do, since the row 1 does not have any 0 other than 0 at C, but the column C has a 0 at the 4th row. So what we will do, we will cross the element at row 4 and column 3. This simply implies that the job C cannot be assigned other than operator 1. Now you will come to the second row. Second row, the operator 2 is assigned to job A, and all other 0 in column A, we will cross it. That means job A cannot be assigned to any other person other than 2. Operator 1, there is no question because we have already assigned. So 2 is assigned with the job A. If you just see the row 2, what we have done, at D we have a 0. So what we will do, we will make it crossed. Similarly at A, row 3 and 4 are 0, we will cross it. So till now we have assigned job A, job C to operator 1 and job A to operator 2. Now comes to the row 3rd. After crossing the 0 at column A, we have only 1 0 at column D. So what we will do, we will simply assign job D to operator 3. That means now we have 3 allocation to 3 operator, 1, 2 and 3. Now comes to the 4th row. In this row, if we move from left to right, you will find the 0 at column B. So what we will do, we will assign job B to operator 4. So in this way you can complete the assignment problem. Now what is the application of assignment and warehousing? As I told you, we can allocate the drivers to the fleet of vehicles. We can select the vehicles for the suitable route. We can allocate equipment for material handling. We can make the arrangement of materials. Then fleet selection problem. So in today's session, we have defined the assignment problem. We tried to understand the basics of assignment problem, and the most important is that where it is going to be used. It is used when you have a certain operators and certain jobs, and you have to assign jobs to different operators. Another important part is that assignment problem is a special type of transportation problem in which the capacity of each source as well as requirement is taken as a 1. In case of transportation problem, the matrix need not to be square, but in case of assignment problem, the matrix should be square. The both models, transportation model as well as assignment models, both are useful in optimization of warehouse distribution. I trust that my session on transportation model as well as assignment model must be useful to you, and you have understood both the model. In the coming sessions, we will try to give you learning by solving a practical example or the numerical example step by step, so that you may have the better understanding. Thank you. Thank you very much.